Gradient descent is an optimization technique to minimize the value of a function. Basically, we have to find the value of the parameters in machine learning algorithms so that the loss function can be minimized, and for that we used gradient descent. But to learn the idea, we will use a very toy example. Let's say the given function that we want to minimize is nothing but fx is equal to x square. And we want to find the value of x for which this function fx can be minimized. So here the parameter is basically x. Let's say we start with a random initialization of the parameter x, that is some random value of x, and we start with x is equal to 5. The idea of gradient descent is that we have to move in the direction of negative gradient of the function, and if we move the parameter in that direction, the function value will get minimized. So the gradient is nothing but the derivative of the function with respect to the parameter. So gradient of fx is nothing but derivative of x square with respect to x, which is equals to 2x. So since x is equal to 5, the value of the function at x is equal to 5 is 25, and we want to minimize this function, so we will update the parameter as follows. So the new x would be the original x minus gradient of fx into alpha. Here alpha is known as step size or learning rate, and it determines that how much we have to move in the negative direction of the gradient. So in this example, we'll start with x is equal to 5. We find that the gradient of fx at x is equal to 5 is basically 2 times x, which is 10. So we update f, and let's say alpha is equal to 0.2. So we update 5 to be 5 minus gradient of fx, which is 10, into alpha, which is the learning rate, which is 0.2, and our new x would be equals to 3. So basically now x becomes 5 minus 2, which is equal to 3. We follow the same step. When x is equal to 3, the gradient of fx would be 3 into 2, which is 6, and alpha is 0.2. So now the x becomes 3 minus 1.2, which is 1.8. Again, we update x to be, so basically this is the new x. We update x to be the current x minus the gradient, which is 3.6, into alpha, which is 0.2. So 1.8 minus 0.72, so the new x would be equals to 1.08, and we continue this way. So basically we started with x is equal to 5, and then we moved to x is equal to 3, then we moved to x is equal to 1.8, then we moved to x is equal to 1.08, and we are getting closer and closer and closer to the optimal value of x, which is x is equal to 0. So this is the idea of gradient descent, that we take the loss function L, and let W is a model parameter, and we know that the loss function L would be a function of model parameters W1, W2, and so on, and W belongs to this set W1, W2, that is the set of all model parameters. And to update W, we take the value of existing value of w, we calculate the gradient of the loss function, and then we move with respect to w, and then we move in the negative direction of the gradient with some step size alpha. So this is the basic idea of gradient descent. I hope this is quite clear to you. See you in next video.